given B being 1, negative 4, 8, C being vector k, and D being 2i 5j minus 5k. Oops, I forgot my vectors over the j and the k. So what we're going to do here is we're just going to add B and C together. So first I write B, and B is just 1, negative 4, and 8. And then when I look at C here, C is really 0 in the I, 0 in the j, and 1 in the k. Because this is really a 1k here. And there's no I and j, so they must be 0. All right, so then I get the vector 1, negative 4, and then 8 plus 1 is 9. So again, this works exactly the same as the two-dimensional. There's no difference. Now moving on to the next one here, B plus D. And we're going to take the magnitude of that, or the norm, they call that in some books. So I'm just going to do B plus D first. So that's 1, negative 4, and 8, plus, and notice here, I'm writing it in component form. And this is 2, and it's just because I'm more comfortable with it, just so you know. So you can do IJK form if you choose. So this is negative 1, and this is negative 5, and then it's the norm of that, or the magnitude. So then when I add those together, I'm really looking at 3, comma, negative 5, comma, positive 3. And how I find a magnitude is I take the square root of 3 squared. Oops, let me fix that. Plus negative 5 squared plus 3 squared. And that gives me square root of 9 plus 25 plus 9. That's going to give me square root of 43, which doesn't simplify any more than that. So that would be the magnitude of vector V plus D. Now I want to do a unit vector in the direction of B. So first off, I have to find the magnitude of B there. Because remember, the formula for a unit vector is V over the magnitude of V. And it's that way because think about it, if I have the length of this and I divide it by the length, that's going to give me a 1. And still in the same direction of V, because this magnitude is just a scalar. So it doesn't change my direction or anything. So that's what makes that okay. So here I'm dealing with B here. So the way I would use this is I would say the magnitude of B, which is going to be 1, negative 4, and 8. And then that would equal the square root of 1 squared plus negative 4 squared plus 8 squared. So that gives me square root of 81, which equals 9. So now I'm going to take this a step further when I'm done with this one, but let me give you an answer for this. So the unit vector then (1, negative 4, and 8 over 9). And then to simplify this, we get 1/9, comma, negative 4/9, comma, 8/9. And there's our unit vector in the direction of B. Now I'm going to add one more in here, and I'm going to call it D. Now this one is going to be, now we're going to find a vector in the direction of B that has the length of 12. So in order to do this, we're just going to use part C here to help us. Because think about what I have here. I have a unit vector in the direction of B, and I want to find a vector in the direction of B again, but that has length 12. So essentially what I can do for this one is, since I know this is a unit vector, and remember, a unit vector is the magnitude is 1. That's what it means. So if I just take that unit vector and I times it by 12, then that would give me a vector in the direction of B that has length 12. Because this magnitude here is 1, and if I take that 1 and times it by 12, it's going to be 12. So now that would give me, simplified, and that would give me 4/3, -16/3, and 32/3. Because when I take this and I multiply it by each of those, because that's what we do with the scalars, 12/9 reduces to, they both have a 3 in the 12 and the 9. So that's going to be 4/3. And just kind of going the same way, we end up with this here as our answer. So it's very simple once I just use and understand that idea of unit vector. Then I can create any kind of vectors I want for the most part with any length.